Okay, so I fixed this code and data set is the same. So let me know if you follow me. Because then I will ask you to do extra credit thing using this code and this data set. And then we make data set panel. And again, as we saw before, over here, it indicates like connection between a year and a particular observation, right? By the way, I can give you extra credit. Do you see line 43? This is the fix I did for the code. If anyone can explain me like what I'm doing and why I'm doing this, I give you 5 extra credit points. We do have some smart people. I have faith in you. So when we imported the data, what is it? When we imported the data, this is not a panel data, right? So let's see, let me show you what happens if I do this. Oh, I guess let's I should be able to show it to you. Let's do this thing. Okay, now nothing exists. So setting working directory, importing data. Okay, setting it as panel, but now basically deactivating line 43. Oh, that's weird. But guys, remember what happened last year or on Wednesday? When I didn't have this line, our year variable became like a bunch of numbers from 1 to 21. And when we tried to use other code to adjust for inflation, this prevented us from running it. And the way to do it is to use this line 43. Thing is, PLM package, when it transforms data to panel data, it makes year a factor variable. But for analysis, we need it as numeric. When we try to like make factor variable numeric, it just gives us a bunch of years. And we don't need that, right? We need to fix a problem created by PLM package. And the way we do it, the way this code works, first step inside, it's like a Russian doll. Inside, we make a year character variable, and then we make it numeric variable, which preserves year, and it's like in the form we need it to preserve. That's like, yeah. Then what we are doing here, here we are taking CPI values, consumer price index values from 2001 to 2021. I got this data on Bureau of Labor Statistics. And what we are doing here, we're creating a data set with values for consumer price index for, and I think we have a couple of economists here. I think this code can be like especially useful for you. So what we did, oops. So now we have years, right? And we have values for consumer price index. Let's double check if I am recording. Yeah, I am recording, thank God. Then we need to set a base year, how it calculates inflation. So, and again, in terms of analysis, it doesn't matter. It could be any year. I decided, okay, let's do 2001. And now we have it, you see? Do you guys follow me? And then we create a function to calculate adjusting for inflation. And the way it works, in line 100, in the line 103, this is if you like just Google how to adjust for inflation, it will give you exactly this. First, it will be value adjusted for inflation. Then this dollar value, it will be your initial value for your variable, right? And over here, we divide your target year, the year you are going to adjust, we divide it by a base CPI value. So we create this function. And then since our data set, you see it has values. Yeah, you see it has values including 23, but we don't have like all the data for all the variables. What we do, I create, I create a shorter data set from 2001 to 21. So we have values for like every single variable in the data set. And then, we create an additional variable adjusted for inflation. We use this function, which we already written, right? Here, the name of the data, $ as usual, and name of the variable with nominal dollars, which are not adjusted for inflation. And then you have comma and your time period. And when you look at the data, you have additional variable which is adjusted for inflation. And whenever you're working with data like for dollars for multiple years, you cannot use nominal data. You must adjust for inflation. And there's a thing about R. Sometimes it can do stuff which like doesn't make sense. So what you always must do, you must check what your code is doing. You cannot just think, oh, code ran, it's correct. Sometimes it isn't. And since we do know the formula for inflation, right? And I'm just checking my results. This is the, let's take, what is it? So we have, let's say Afghanistan. This is Afghanistan for 2002. This is adjusted value, right? And this is initial value, right? So what we do here, we multiply initial value basically by inflation. And when we do it, we have it. This is it. This is how you adjust for inflation using R code. And let's move to, let's do a bunch of other stuff, and then I will give you extra credit assignment. Let's create a bunch of chunks where we are going to place our code. And again, try to do code like within chunks. Don't like place your whole code to one chunk, because this way, if you have some kind of issue with your code, it's like easier to check whether or not your code, like what the problem is. Okay, so let's see. I want to run a regression on GDP, and GDP in our data set is nominal. So we need to adjust it for inflation. We cannot just use it the way it is. So let's see. We do have function already, right? We do have data set for inflation already, right? So what we need to do, oops, uh, GDP. GDP adjusted for inflation, right? And here, GDP imputed. Let's hope it will. And by the way, always save what you are doing so you don't lose your code. Like click here all the time, please. Oops. Okay, so let's see. And we have new values just for like say, just like, let's see if it made any sense. So this would be this would be our initial value, right? Oops. Let's do it here. So let's see. GDP, inflation adjusted. Inflation adjusted. And we just, oops. Oh, let's double check one more time. Okay, 39. Okay, let's see, 36. Yeah, 36. So the code did work in the way it was supposed to work. We like checked it ourselves, right? Do you guys need a minute to do it? Because I will ask it to do it for extra credit. You will have to calculate some other variables. Not calculate, like adjust for inflation. Which one? Which line of code? 149? GDP inflation adjusted. But you can give it any name. I just like to use acronyms. It doesn't matter. But I guess it makes sense to give to have like names which are meaningful. Yep.
That like normally you have a model in 62. To get that from data.
Yeah, like what we needed to do, we needed to check if calculation adjusting for inflation was performed correctly. So what we do, we go to actual data and we go, you see GDP imputed 2002. This is original nominal dollars, right? Not adjusted for inflation. So when we like do this simple mathematical formula, we are like getting this number. So we're just checking, did it do what it was supposed to be doing? And like we know it happened. You check you take your original value, not adjusted for inflation, and you see like whether or not it happened. So now let's just like showing like how to do this stuff. And let's do like a model using values already adjusted for inflation. So let's do GDP model. GDP inflation adjusted. This is our dependent variable, right? And then we use what is tilde, right? Thanks for teaching me some English. On this one. Okay, tilde. And then we do a bunch of independent variables. So sanction status is probably going to be useful variable. And let's make it problematic intentionally. So we do have a bunch of other variables which are like related to sanctions. So let's see. Sanction status variable is a variable which says whether or not there was like sanctions imposed by United States against a particular country in a particular year, like any kind of sanctions, right? But then what we did, we created a bunch of variables for specific types of sanctions. So let's do like SS trade, like trade sanctions. Plus sign. Let's see what else we have. Okay, let's do SS financial. Did I write it correctly? SS financial. And then if I remember right, we just comma and name of the data. And then we do summary. GDP model. Running linear regression model for GDP adjusted for inflation. Oops. Okay, let's see. Yeah, I see what the problem is. So, what can you say about this adjusted R square? It's like how much percent of change in GDP is explained by this model. Yeah, it's like 0.8, yeah, less than 1%. So it's like a very bad model. We won't be able to publish paper if we run this model and try to publish, right? So let's see, and this is intercept, remember? We discussed it. So these are independent variables. So what can we say about sanctions status? Is it statistically significant or not? It has 1 star, and these are the hints below. What 1 star means? Yep. 95. You see over here, like 1 star, 95. Yeah, 95. And then it is positive. So basically, what it means, and since we know we have dollars, right? We can say that if country is not under sanctions, like its GDP is like increases by this number of like dollars, because we know what the value of the variable is, right? So let's see. What about trade sanctions? Is it statistically significant or not? What level? 95, 95. And what about financial sanctions? Yeah, it's like 99. Yeah, this is like, and let's just play around and add additional variables. Let's add FH, Freedom House, like political score, like this country is free or not, it might affect GDP. Like we do know that wealthy countries, with few exceptions, are democracies, right? So let's add. Okay, and when we added this variable, like actually you see adjusted R square increased. Do you see it? Not much, but a little bit. So it means when we add variables, we are able to explain our dependent variable like more fully. And let's do let's see. So let's check for heteroscedasticity and then multicollinearity. So go to like this file, Kostiaev linear regression week 9, and just like copy paste this code and make like small edits. So we named our model GDP model. So we just replace it over here. And don't forget to replace it here. And let's run it. So do we have heteroscedasticity or homoscedasticity? Pick up. Is it random or not? It doesn't look random. There are like certain patterns, right? So there is a heteroscedasticity. And now let's check for multicollinearity. Again, you just copy paste it. Oops. To check for multicollinearity, we need this car package. It allows us to run this check for multicollinearity. So here I have this hashtag, which prevents me from like installing it because I already have it. But you need to remove your hashtag in front of install, okay? And then again, in line 204, we just, oh shit. Yeah. And we close it. Oops. And then I gave you hints how to interpret it, right? So let's see. Oh, okay. So how we can interpret these values? Do we have multicollinearity? Is it larger? What do I say here? Like a value between 1 and 5 indicates like moderate correlation. Value greater than 5 indicates like severe correlation. So like we have moderate, but like not severe. So this will be, let's do extra credit assignment. I am asking you, and I will like just type it. So I am asking you to adjust for inflation exports. And then I'm asking you to run a linear regression with experts adjusted for inflation as dependent variables and a bunch of independent variables. And again, like variables which make sense could be obviously like sanctions variables, right? And especially, let's say, what is it? Trade sanctions. It might make sense, right? If you have a trade sanctions, they might affect exports, right? And then you can have a bunch of variables for like Freedom House, like whether or not country is free or not. So let me, and then you have to run all those checks for heteroscedasticity and multicollinearity. I posted it on, like it's posted. If you followed me in the last like 20 minutes, like could have it. It's in the Blackboard. Yeah. It's in week 9. Yep. Say it again. Yeah. Say it again. You had a 300,000 something number. I went to like original data sets. When you do it, you go to like original data set, the value which have not been adjusted for inflation. Okay, let me stop recording.